We are group number 72. Today, we will be talking about how education serves as a catalyst for growth, which is the topic of our project. Traditionally, literacy rate is equated to a country's educational progress, and the GDP growth is considered equivalent to its overall growth. When in reality, both of these factors are multidimensional, as we will discover with our analysis. This dashboard can be used by policymakers to support their arguments in advocacy efforts or for funding proposals. This dashboard will help them demonstrate the link between educational investment and societal gains with clear, compelling visuals, which can help them secure support and funding from government bodies or international organizations. To create our dataset, we have aggregated data from about 25 plus datasets. Our datasets are majorly from a website named ourworldindata.com, whose sources include UN SDG indicators, National Center for Health Statistics, and National Center for Nutritional Survey. With the help of Python, we did our initial data pre-processing, which included cementing together these datasets, imputing missing or zero values with the help of interpolation, applying k-means clustering to group the countries into clusters of developed, developing, and underdeveloped nations. After pre-processing our dataset, we divided our data of 47 features and 4200 data points across 5 verticals: governance, social justice and inequality, health metrics, environmental hazards, and economic prosperity. After cleaning and processing our data, we used it to create this dashboard with these 5 visual elements made in accordance with the guidelines that we learned in our class. As per the taught mantra from Ben Schneiderman, our PCP provides the user an overview first, and with the help of interactions enabled within and across the dashboard, the user can zoom in and obtain detail on demand. We have made use of repeated white grids along with a light color for bigger spaces, which is the background, and darker colors for small spaces to create an effective visual contrast. The dynamic labels are generated neatly next to the charts to provide immediate context about the plots. Now that we know what this dashboard is about and what it does, I will hand it over to Amir to present some special insights from our data.
Jumping right into the demonstration of the dashboard, here we have the education as a catalyst for change dashboard. Just a heads up, as Sakshi mentioned, we had three clusters that we have received as a result of k-means. The parallel coordinate plot is colored with the result of the clustering. The clusters are named developed, developing, and underdeveloped countries. Next, we draw our attention uh, to the year slider. So we have roughly 20 years of data for all the countries, and at one point the dashboard represents 1 year worth of data. We have a play button over here which will allow you to play through all the 20 years of data and change the all the elements of the dashboard correspondingly, and I'll show you a demonstration of this in some time. Furthermore, we we draw our attention to the x-axis, the education metric, and the y-axis, the growth metric. So we try to select education on one hand and growth on the other hand. And in growth, we are dividing growth into multiple verticals like health, environment, governance, economic development, and gender bias. So the different types of plots that we have are the scatter plot for bivariate analysis, the choropleth map for having a view of the world at a glance. We have the histogram in case we need some counts of elements in certain ranges, and we have the parallel coordinate plot for multivariate analysis. Um, so let's demonstrate how someone would potentially use this dashboard to derive insights. So let's start to explore the verticals that we have. Let's first try to explore the gender bias vertical. For measuring gender bias, we use the gender inequality index. Uh, and we notice first in our scatter plot, mm, that the relation between gender inequality index and the secondary school enrollment is that of an inverse relation. Wherever the secondary school enrollment is high, the gender inequality is low. Wherever the gender inequality high, the secondary school enrollment is low. Let me just play the play the data for multiple years to get a sense that this is kind of the general trend that has been happening for all the years that were present, right? Yep. So one more thing to notice over here is the color of the choropleth map. Right now it represents the year 2000, and it's fairly dark, but as I move it to the year 2020, it will be suddenly it will move to a lighter shade. So yes, this has moved to a lighter shade, indicating that gender inequality has been reduced in the past 20 years across the world. Uh, Now, if we want to single out a few points, we can use brushing and linking that is present over here. The brushing, we brush on the scatter plot, and the corresponding countries do get selected on the parallel coordinate plot and in the gender inequality index in the choropleth map. First, we see wherever the gender inequality index is high and the secondary school enrollment is low, we see mostly blue lines, which are the underdeveloped countries. We move on to the next kind of a cluster, uh, which is um, which is kind of our blue cluster, and which is kind of our orange cluster, which represents the developing countries. We can see India is over here in the developing countries, and finally we kind of move to the developed countries, where the secondary school enrollment is high and the gender inequality is also low, which is a very good thing. um, so and we see just one more thing, that most of these countries are from Europe. um, so for example, if we have, say for example, this country, and we want to identify which country it is, we can simply hover over it, and we find the name of the country. We can also, if we want, zoom in wherever required to identify smaller countries that are present. So let me just go ahead and reset the dashboard. Next, we try to measure life expectancy versus literacy rate. So on the education metric, we pick up the literacy rate, and on the y-axis growth metric, we pick up the life expectancy at birth. Here, um, let's first reset the data, and now we pick education metric. We should be literacy rate, and this one should be life expectancy at birth. And we can see that I'll show you a different way of playing through the data. We can I'll just use my arrow button for this, so it allows me the speed that I want. Now, while I'm going through the years and viewing the scatter plot, we can see that all the points in the scatter plot are moving towards the top right corner, which is also kind of a good thing, which means that life expectancy is increasing, and at the same time literacy rate is also increasing. And the pattern seems similar over all the years, which basically means that they have kind of a positive correlation with each other. uh, Finally, we again reset the data set, and we try to measure the last vertical that we had, which was the environment vertical. We can see in this environment vertical that not much relation between the annual CO2 emissions and the secondary school enrollment. We see in 2005, the annual CO2 emissions of USA, Canada are a bit high, but in the year um, 2020 it's low. So over the years, this change has kind of happened. This dashboard allows us to identify such changes that have happened, or such improvements that have happened over the years. So let me just again refresh it, and there you have it. This is what our dashboard is. Thank you for listening.